Hi everybody, Scott Stanchfield here. Let's take a look at speech in an application. So we're going to take a look at an application that implements a little text adventure game here. And I have three versions of it inside of here. I have main activity 1, main activity 2, main activity 3. Now main activity 1 has no speech in it. It's just the base application. You can kind of use that to take a look at how the application would work without speech. And we'll run each of these just so you can see how it goes. But let me talk about the structure of this project first. Note that I have two modules in here, app and language. And you can create another module by right-clicking on the project up here and saying new module. That's useful for having like some separate compilation. In this case, this language is strictly a Java project, which can have Kotlin code in it, but it's not going to have any type of Android code inside of it. If we take a look at the build.gradle inside here, we'll see it's much simpler. We just have, this is going to be a Java library. I'm using Kotlin, so I'm going to compile Kotlin. And I'm using Antler, so I'm going to compile an Antler grammar into some Java source. And then just a few other things here, like my dependencies are just on Antler. Everything else is just straight old Kotlin code. So let's take a look at what's inside of here, first of all. I have two subdirectories under source main Antler and source main Java. Source main Antler defines my grammar, and if I open him up, we'll see here's my grammar for this. And in here I'm saying Java is my language. I have a couple headers here which just put package statements at the top of the generated code. I have a little helper function here that says if I get a recognition error, so meaning I see something and I don't understand it, I want to throw in runtime exception. By default, it's just going to end up spitting out a piece of text during the compile, which isn't terribly useful. We actually want to have it stop the compilation. And then I'm defining what a command is. This is a really, really super simple parser here, where we're putting together the words in our sentences and then generating commands. And really all we're doing is matching the words, get some word from some word, and then calling functions in our game object that we've passed in here. So this is a really nice and simple one. We're not doing any type of abstract syntax tree creation here. A lot of times when you're using Antler, you're using it to translate from one language into another. So maybe you've created your own little language or you're doing a compiler or a translator. You're going to parse the input, create a tree to represent it, and then you have a tree parser that you can walk to generate code. But this particular one, we're just using this to match things and call functions in the game object. Nice simple parser. Let's take a look at the actual code that we're using inside the model. So we'll start with data types. I set up a hierarchy here of interfaces, and what I'm doing is I'm taking advantage of Kotlin's ability to have default function implementations inside interfaces. And this allows me to create mix-ins. I can define implementations in one place and then just pull them in to other places. Like for example, named says I require you to have a description, and I'm going to have a name and a full description which have default implementations. So the name, his default implementation is, let's just go ahead and get the name of whatever class we have. So if we came down here, for example, room, if room was a named thing, his name would be room. But I mean, the real thing we're going to use it for is when we're actually doing our data, where we have safe, letter, key. It's actually going to use those as the name of the objects, which is kind of cool. So my default implementation and name is that, but you could override it if you want. And then for the full description, my default implementation is just whatever the description text is. Some things are going to add more information, like which objects are inside of a room, things like that. An item is something that's just a named thing. A movable item is an item. And I can use these so I can check to see is something movable or not. A container is also a named thing, so he's going to inherit those same functionality. And inside here, he has items, some functions to be able to say, is it empty, and what are the names of the items? Items is just a map of things. The full description says if I'm empty, print out empty. If I'm not empty, print out the names that are inside there. Printing out the names is just going to say if it's empty, don't do anything. Otherwise, I'm going to create a list of a something, a something, a something underneath of it. Have some functions to add and remove things. And then I'm overriding these operator contains. Now remember with Kotlin, if you override operator contains, you're going to be defining the in function for our object. So we're actually going to say any container, you can say something in that container. And I'm just delegating that down to, if you're trying to check for an item, is the item's name in my keys of items? If you're passing in the name of something, is that name in the item's keys? A couple little helper functions in here. I'm going to try to find an item inside of me or not. So I'm going to say if I can get it. Otherwise, I'm going to throw an exception. And this actually makes my life much, much simpler. I set up the way that we're interacting with this model in a much more functional way, so that if there's a problem, I throw an exception. Otherwise, I return an object. And I can compose these to build higher functions pretty nicely. Find or null is just going to return item name, just exposing that. Now I also have a find container item, and what he's going to do is check to see which item I have, and if I don't see him, he's going to cast him to container item. Now I should have actually had this be find item name. I thought I had modified it to look like that, so this is actually a little simpler. I'm going to try to find it, and then I'm going to try to cast it as a container item, which is really all this function is doing for me, so that I can get something as a container much more simply. I'm not sure how that, I know I had changed this code before, but somehow it got changed back. I'm not sure. I must have been doing something else and undone one step too far at that point. Now watch that totally break my application. A container item impl, this is actually a hard class, a concrete class for a container item, which is defined down here. Now notice that a container item inherits from item and container. So I'm using the mix-in capabilities of the default methods in item and container and pulling them together. Really cool. And then I'm adding some extra information in there to say, is it locked, is it open, and what's the key for it. So inside of here, I'm overriding find to say only if it's open, do these things. And this if open function here says, if I'm not open, throw an exception, otherwise execute the block that comes in there. So this will stop our processing at any given point to tell you if something's not open or not. And it's a nice little simple method there. Here's where I actually did that function I was talking about. So actually I don't need this one because the superclass calls find item name and casts it. So I can delete that like that. Get full description is just going to tell you if it's locked, open, closed, things like that. And if it's open, it's going to list the names of the things inside of it. Then we have some commands that the user is going to execute. The user wants to open something, the user wants to close something, the user wants to lock something, and then the functionality to do it. So is it already open? Is it locked so you can't open it? Otherwise, I'm going to open it and report that you open it. So this type of pattern we're going to see all over these objects. They're going to have these functions that say the user wants to do something. Let me check my state and see if it's okay. If it's not okay, throw an exception. If it is okay, go ahead and change my state. So I'm not going to go through every single function. You'll see that it's the same kind of pattern over and over again. Check for a bunch of bad states, throw exceptions if so. Otherwise, do what you need to change the state. A room has several directions, north, south, east, west. Note that these are actually lambdas coming in. And I made the mistake when I first did this of actually just saying north is a room, south is a room, east is a room, west is a room. And the problem is if you have circular dependencies like we do in this definition, it won't work. One of them is going to end up being null. And I had a case where the porch was pointing to the hall was pointing to the porch, and the hall couldn't resolve the porch yet and ended up setting it to be null. So instead what we're doing is we create these lambdas. That gives it enough separation that it can create the other object before this guy actually gets executed. So in here, oops, don't need this. This was part of my debugging. Get rid of him there. I have my items that are inside my room and some little helper to print out what you're seeing here. This guy here creates a list of which directions you can go by checking each of these. And if he sees them, then he's going to run each of those functions, north, south, east, west, to create the object or actually get access to the object And then poof, he has this map set up of which directions we can go. And so the get full description actually is going to tell you which directions you can go there. The move function is going to return which room you're actually going to. And once again, I'm calling each of these functions to resolve which room it is later on. And then a movable item impl is just one that just implements movable item. So that's all our basic objects there. Not a whole lot going on. The data is where we're actually defining the objects inside of our game. And so there's not a whole lot in here. A key is a movable item, and then it has a little description, a letter, movable item. A safe is a container item. He starts off locked. He starts off not open. He uses that key as his key. And then here's the items that are inside of it. Then I'm defining my rooms. I have my porch, bedroom, study, and kitchen. And we'll see that they have pointers to the things that are the places that you can actually go for each of those directions. So that's pretty much it for the data there. The game is just going to have functions that actually are called from the grammar to actually change the state of some of the objects. So we're going to start off by defining an inventory object, and I'm creating an object so it's just a singleton. There's only one inventory in here. He's a container. He has some items. He has a little prefix saying your inventory contains something or your inventory is empty. And you can put stuff inside of him. I'm defining that command exception that we can call. Then the actual game itself keeps track of the current room and the current command that you're actually executing. The report function just turns around and calls this reporter up here. And then we have functions for each of the commands the user does: drop, get from, and so on. So each of these guys, the way I've defined them, drop is just defined in terms of calling move. Move is defined in terms of finding something inside something else. So the item we're concerned with is find this name. If that find fails, it throws an exception. If the move fails, it throws an exception. And this way we can nest these things and do it kind of in a functional manner without having to do a lot of repetitive code. If we got past this with no exceptions, we just report what happened. So get is defined in terms of get from the current room. Get from is saying I'm looking for this item inside this container, like if I'm trying to get something from the safe. That becomes a call to get from, let me find that container in the current room, and so on. So we're nesting these in a much more functional manner rather than trying to do things by having a whole bunch of if statements inside of things. Let's see, so open, close, unlock, and lock. These are all just delegating to the containers. So what we do is we try to find the container item. Once again, we're delegating to that helper function to locate it, which may throw an exception. If it didn't, we're going to call open on that object. Examine is just putting out the descriptions of things. Quit is calling on quit that's passed in. So if the user types in quit, it'll end up exiting the application, and so on and so on. And then go is just changing the current room based on which direction we went to. So that's really the data part of it. You'll see this application is pretty straightforward that way. Not a whole lot of data. In our app level here, if we take a look at this build dependencies.gradle, notice that we're referencing that other project. So we have implementation project : language. That is saying I want to pull in this project as a dependency for implementations. Now let's take a look at our code inside of here. Whoops. So we have some common stuff in here, just a little common helper text field. Recognition listener is our listener for the speech recognition. So I set up a null recognition listener that just doesn't do anything, so that when we actually use it, we can only override a couple of the functions we need. Just makes it a little bit cleaner in the actual call spot. You don't have to do this. You could actually define all of these. But I like kind of doing these types of things if you know that you're only going to need one or two of them, like ready for speech and results, things like that. This parse file here is a helper that actually does the call to the Antler parser. So that way I don't have to put all this code inside all of these activities. So these functions we have, first of all, setting up an error listener, which is an Antler error listener. all of these functions, I'm just having them throw an exception. Just so that if there's a problem, boom, it throws an exception. We can catch that and say, hey, the command wasn't recognized. This parse function is acting as an extension on game, and we're setting up, first of all, the input stream in Antlers. This is a stream of characters coming in by taking the command, lowercasing it, and we're going to pass it in as a stream that the lexer can read. The lexer reads the input stream. We create a token stream that reads the output from the lexer. And then we create a parser, which reads the token stream. So the lexer is going to push things into the token stream. The parser is going to read things from the token stream. Set up our error listeners. Set the command inside the game object so that we know what it was. And then call the parser, that's the thing that had the grammar defined, passing the game in. So he's going to parse the command and then call the appropriate thing on the game if he can. If we got exceptions, we're just going to say command not recognized, try again. Boom. Unless the command exception had a message, in which case we'll report it. So if the command exception said something like, the thing is not open, we're going to report that. If there isn't a message inside there, we're just going to say we didn't recognize the message. So that's our little parse helper. Now we can actually take a look at the code. Now this first one here, this guy is just doing it as typing in text entry. So he's pretty straightforward. We have 3 mutable states. I didn't define a view model on this because I wanted to have this be separate for each activity and not have to have too many files in here. So I'm just defining these mutable states directly inside the activity. Note that if this activity gets recreated, these mutable states will be recreated. So don't rotate the phone when you're running this guy. In my onCreate, I create an instance of my game. And then I start the game by looking. This will describe the first room that you're in. The UI itself is going to be pretty simple. I'm going to call UI, passing in those 3 mutable states and what to do when it hears that there's a command entered. In which case I'm going to say, hey game, please parse the command. The main UI itself, I'm going to set up a scaffold that just says adventure at the top of the screen. And then I have a column which has some stuff inside of it. So first of all, a text field where the user can enter the text. And there's a couple little things I did inside here. One is this guy here. Keyboard options where I said IME action equals go. This replaces the enter key on the virtual keyboard with a little button that says go. So that's actually just kind of nice there. And that's where this keyboard actions comes in. This keyboard actions is called when this button is actually pressed. So if the user presses this, that's when we're going to call on command to tell the outside world that we're executing a command. And then down inside here, I also added in this little on key event handler saying if the user hit the enter key, do the same type of thing. And this was more of a convenience for me. So if they're using a physical keyboard, which I'm going to be doing in this demonstration, and I hit enter, it's actually going to run it. So it just makes it a little easier for me to run the demonstration rather than having to constantly click the thing on the screen. And then I'm just putting out these 3 text fields, the status, the message, and the text. So that's all this application is. Not a whole lot going on. Let's go ahead and run it on the, I'm actually running a real device here because I need the real device to actually do the microphone. You can't do that on the emulator. There may be some way to set it up, but I haven't found that out yet. So here's the first version. I'm going to click in here where it says enter command. And note that it says, this is the front porch of your house. You can go north. I'm going to say go north. And now I'm in the hall. This is the main hall of your house. I can go north, south, east, west. So I'm going to go west. This is the kitchen. It's a room you never use and really aren't certain why you even have it. You see a key. Let's get the key. And now if I say inventory, I can see my inventory contains a key. And I can go east, and we'll go north from there. Now I'm in the study, and you see a safe there. If I say examine safe, it's going to tell me it's a very heavy lockbox. There's a keyhole, and it's locked. So I'm going to say unlock safe. You unlock the safe. Let's examine the safe again. Very heavy locked box. Now it's closed and not locked. So we're going to say open safe. And let's examine the safe again. And now we see that it's open and the safe contains a letter. Get letter from safe. You got the letter from the safe. And then if we examine the letter, it says you win. Ta-da! Now I didn't put any logic into the game to detect when you win and do anything interesting. So this is basically my win state. So I'm going to say quit, and boom, I'm out of the application. And that all worked really nicely, but it was just done via text. Let's take a look now if we started to put in some text-to-speech and some speech-to-text. So if we come up to this next version here, this guy changes things up just a little bit. And this is going to be using an external intent to run the speech recognition for us. So the main stuff that we're changing here, you'll see that we now have this text-to-speech that we're keeping track of. And we're going to set him up inside of my onCreate. And this text-to-speech is a new instance here where I'm going to set my language. I'm going to set the utterance progress listener. And this progress listener is just going to change the status. Shh, I'm speaking, or when he's done speaking, say nothing. And if there's an error, let us say there's an error speaking. So that's pretty straightforward there. In the game, we're changing our reporter slightly so that not only are we putting the text on the screen, we're going to have the text-to-speech speak the message as well. For the speech-to-text, we're adding a little microphone into the text field on the screen. And if you tap that microphone, we're going to launch that recognized speech via intent, which we'll see in a minute there. Let's actually try to go to there right now. So see, he's defined up at the top here. This guy is saying, I'm going to register for activity result using that get speech. Let's take a look at him. So this is down at the bottom of that file. He is setting up a contract to be able to create the intent and parse a result. And for the results, I just used a sealed interface here that has 3 subtypes: canceled, error, or command. Canceled and error are just objects. We're just saying in general, it's the same instance every time, not passing any data. Command is a data class, so we actually get the text that was recognized, or the text the user said, so that we can pass it on to the parser. So we'll see inside here when we parse the result, if it was okay, we're going to grab the results, take the first result, and create a command object out of it. Otherwise, if it's canceled or an error, we're going to return the speech canceled or speech error objects. So when we register for this guy, anytime we launch him, after we get a result, we're going to come down to this section here, take a look at the result and say if it's a command, we're going to parse it. If it's an error, we're going to report a little toast saying there's an error. If it's canceled, we're just going to say speech canceled. So now inside of our UE, our outline text field, I'm adding in this trailing icon, which is a little microphone. And when you tap that, we're going to call that on microphone tap. So that's really the only change that I'm making down here in the actual user interface itself. So those are all my changes. Let's go ahead and try running this one and see what it does. Now when I run this, unfortunately there's not really a good way to capture audio from the device, especially when I'm using the microphone, when I'm using the speaker on the device and using the microphone on the device. So I'm going to actually hold the physical device up to my microphone. This is kind of a real hack workaround here, but it's really the only thing I can do right now. So when I hit speech 2, you should hear it say that we're on the porch. So let me come in here and hit speech 2.
This is the front porch of your house. You can go north.
And it's not displaying any of the text. That's interesting. So I paused the video and investigated a little bit deeper here, and turns out this is a race condition. So what's happening is this text-to-speech ends up kicking off a job to hook up to the speech recognition service, and at some point calls the rest of this code. So it's kind of non-deterministic when the game is going to get initialized, and in particular, this text is being set. So what ends up happening is this kicks off doing its job, then the GUI gets set up, and apparently the race is between the check here to see if the text is changed and the text being changed up here. So if instead we move the set content up inside the text-to-speech's I'm ready block here, we won't actually start setting up the GUI until we've already set up the speech recognition. So in this case, this actually makes sure that they're both related to each other, and there's no lack of determinism. And then we call the game.look after the GUI's been set up. So if we try running this,
This is the front porch of your house. You can go north.
Now we see that that actually works. So if I came in here and I typed in go north, wow, and then hit go.
This is the main hall of your house. You can go north, south, east, west.
So the text-to-speech part is working just fine. So I said go west.
This is a room you never use and aren't really certain why you even have it. You can go east. You see a key.
So far so good. And now, instead of typing text, I'm going to hit the little microphone button up here. Go east.
This is the main hall of your house. You can go north, south, east, west.
Go west.
This is a room you never use and aren't really certain why you even have it. You can go east. You see a key.
Get key.
You picked up the key.
And so on and so on. And so you can see this is actually working out pretty well now. So now let's take a look at the next kind of way to kind of automate this. So instead of having to hit that button each time, and instead of having that dialog pop up to tell us, hey, we're recognizing some text, because, look at this. This thing's kind of obnoxious here. Inventory.
Your inventory contains a key.
Inventory.
Your inventory contains a key.
So it looks like it's working, but that dialogue coming up is really distracting, and it has that little toast that comes up with it saying that, trying to explain to the user that we're transmitting information between two applications. So instead, we'd like to set it up so that'll be a little bit more automated. So now we're going to take a look at main activity 3, and this is going to be using the speech recognizer inside of our application as opposed to going out to another application to talk to it. So the types of differences we're going to see inside here is we have this speech recognizer here, and this intent has the language model and the language passed in there as well. We're going to use that. The setup up in here is the same as we did for the last assignment. But the trick is this guy right here. So whenever we're going to want to start our speech recognition, we need to do our permission check. And this sets it up so that at the point the user is actually requesting to do something, or in this case, the application is going to ask to do something, it actually asks for the permission right at the last second. So what we do in this function is we're checking to see, do I have record audio permission? And if not, I'm going to kick off a little dialogue here to ask them, saying this application uses voice commands, please allow recording on the next pop-up, blah, 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 blah. This is a little hint ahead of time telling the user what to expect and why we're asking for record audio permission. Sometimes it's not particularly obvious why something is being asked for, and so you want to have a little prompt to help let them know. So in this case, if the user says cancel, we're just going to finish the app. We're just going to close it away. If they say okay, then we're going to ask for the recording permission. So we're going to do that launcher like we did for the other types of permissions. Launching to ask for record audio. In this case, it's just a single permission we need, not the multiple permissions. And in here, this guy is going to use the request permission contract, which is already defined by the platform. We'll register that for an activity result. He'll set up the needed intent to talk to the permission application. He'll get the permission and return the result back to us. And then we can take a look and say, if he granted permission, go ahead and start listening. Otherwise, we're going to tell them, hey, we need recording permission. This is kind of useless without it. So once again, the try to restart, if we don't have permission, kick off the dialog, which will ask for permission eventually. If we do have permission, start listening. Otherwise, if we kicked off that dialog, that goes and launches this recording permission. And then if it's granted, we go to start listening. So start listening is how we get into our speech recognizer. So we'll see inside here in start listening, we're going to kick off the speech recognizer. We want to make sure that it's happening on the UE thread. So we're doing this lifecycle scope launch dispatchers.main. And we're going to start off by saying if the speech recognizer is null, we're going to create an instance of it. Otherwise, we're going to just do a start listening on the speech recognizer. So inside here, we're going to first of all check to see, is speech recognition available on this platform? And there's some devices that won't have the speech recognition service installed inside of it. So they'd actually need to install it. And there's a whole process to go through there. I don't want to go down that rabbit hole. On the device I'm using, it has it, so we'll assume that that's okay. Most devices do have that service installed, but just keep in mind, this is something you should be checking for. Otherwise, if the speech recognizer is available, we're going to go ahead and create him, set up a recognition listener, which is going to handle the response from the user. So to start with, when we're ready for the user to say something, we're just going to change the status. When we get results back, we're going to grab the results out, similar that we did before, grab that array, get the first element, and then tell the game to parse it. If there's an error, we're just going to say there was a recognition error. Now note that with the errors, they give you these integers, and 7 and 8 seem to be the problematic ones for a lot of people. From what I've been seeing online, the speech recognizer has gotten better over the years, but there's still people having a lot of trouble with it, and there are some third-party libraries that try to help ease this out. Part of the deal with the 7 and 8, if you get that, you really have to stop and restart the recognition. And so that's what I'm happening inside here is I'm saying stop listening and start listening. Note that stop listening and start listening have to be called on the UE thread, which is why I'm doing the LifeSampleScope launch dispatchers.main. So we pass in that recognition listener, and then we can ask him to start listening. If the user pauses the activity, we want to stop listening and cancel any listening that's currently in progress. The UE, in this case, is much simpler because we don't have an input field. We're just displaying the status and the text on the output. And we'll change the title to be Auto Speech Adventure. Everything else stays the same, so there's not a whole lot going on here. It's just that we're now handling this internally. Note that we do need some permissions. So if we take a look at our manifest, we have the record audio permission we need for this. And for this particular branch, we need to say that we're going to visit the Android speech recognition service on the device. This other guy was needed for the intent-based one that we were sending off. So let's go ahead. I'm going to change the main application to run to be number 3. And we'll go ahead and run this. And let me.
This is the front porch of your house. You can go north.
And at this point, it's asking us for that permission. This is that dialog that we came up with to let the user know why we're asking permission. So the application uses voice commands. Please allow audio recordings on the next pop-up to use it. I'm going to hit OK. And then it's going to ask me, is it OK to record audio? And I'm going to say, only this time. Go north.
This is the main hall of your house. You can go north, south, east, west.
Go west.
This is a room you never use and aren't really certain why you even have it. You can go east. You see a key.
Get key.
You picked up the key.
Go west.
Command go west not recognized. Try again.
Go east.
This is the main hall of your house. You can go north, south, east, west.
Go north.
This is where you pretend to work. You can go south. You see a safe.
Examine safe.
It is a very heavy lock box. There is a keyhole on it. The safe is locked.
Unlock safe.
You unlock the safe.
Open safe.
You open the safe.
Examine safe.
It is a very heavy lock box. There is a keyhole on it. The safe is open. The safe contains a letter.
Get letter from safe.
You picked up the letter from the safe.
Examine letter.
It reads you win.
Quit. And there we go. So there were a few little issues with the GUI being updated. I've got to take a look at those and hopefully post some updates on that at some point. But overall, the application's working pretty well. And you can see how when you start automating the speech to be more of a conversation, it can actually be a little more pleasant for the user to interact with. And they don't have to do as much typing. They don't have to constantly hit a button to do the speech recognition. Something like that might be useful for some sorts of applications, especially if you're dealing with an application that you really want the user to be using hands-free. So if it's anything related to driving, that would be a good way to deal with it. I would recommend, if you really want to use this, you take a look into some of those third-party libraries. I put a note in here about, we're talking about the recognition error. There's one called Droid Speech 2, which is fairly new. It is a Kotlin-based library, and that does handle a lot of the edge cases behind the scenes. So that might actually make an application like this much more robust and easier to deal with. But whatever you do, don't try to go and find a reason to put speech in an application. Only do it when it's something that actually makes sense for the application. If the user has their hands full and you want to have them be able to control the application, that's a good way to go about things as well.